Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Azhar Wafiq bin Muhammad Azmi. Registration number saya 33DPE19F 1112. Lecturer saya Puan Hajah Aminah. Sebenarnya tajuk untuk saya bentangkan ialah heat transfer direct contact, iaitu quenching tower. Sebenarnya working principle of heat exchanger. Heat exchanger work because heat naturally flows from higher temperature to lower temperatures. Therefore, if a hot fluid and a cold fluid are separated by a heat conducting surface, heat can be transferred from the hot. Rajah di bawah tersebut menunjukkan tentang bagaimana working principle tersebut berlaku. Seterusnya saya akan menerangkan tentang log mean temperature difference method ataupun nama singkatannya LMTD. LMTD is used to determine the temperature driving force for heat transfer in flow system. Most notably in heat exchanger, the LMTD is a logarithmic average of the temperature difference between the hot and cold feeds at each end of the double pipe exchanger. For a given heat exchanger with constant area and heat transfer coefficients, the larger the MTD, the more heat is transferred. The use of the MTD arises straightforwardly from the analysis of a heat exchanger with constant flow rate and fluid thermal properties. Seterusnya saya akan menunjukkan tentang working LMTD ataupun formula yang ada dalam LMTD. LMTD sama dengan kurungan DT tolak DTI kurungan per IN kurungan DT kosong per DTI kurungan. Sebenarnya LMTD sama dengan logarithmic mean temperature difference dalam kurungan darjah F dan darjah C, iaitu darjah Celsius. Seterusnya for parallel flow, DTI sama dengan TPI tolak TSI sama dengan inlet primary and secondary fluid temperature difference. Seterusnya DTO sama dengan TPO tolak TSO sama dengan outlet primary and secondary fluid temperature difference. Seterusnya untuk counter flow, formulanya ialah DTI sama dengan TPI tolak TSO sama dengan inlet primary and outlet secondary fluid temperature difference. Seterusnya DTO sama dengan TPO tolak TSI sama dengan outlet primary and inlet secondary temperature difference. Seterusnya ini adalah rajah logarithmic mean temperature differential. So kita boleh tengok di sini bagaimana temperature tersebut berlaku. Seterusnya saya akan masuk kepada quench tower, dan ini adalah introduction of quench tower. There are many process unit quench tower including fluidized catalytic cracking unit, vinyl chloride monomer unit, ethylene oxide, ethylene glycol and ethylene pyrolysis cracking unit. Director effluent from the process requires cooling for further fractionation, and therefore the temperature is reduced or quenched. Typically, quench tower utilize one or more heat transfer sections or pump rounds to move heat from the column. The use of heat transfer section or pump rounds result in a better distribution of tower loads than would be the case if all of the heat were removed in the tower overhead. Additional benefits include reduced tower diameter at the column upper section and the recovery heat can and the recovery of heat at a higher temperature. This higher level of heat can then be utilized in the process for improved energy recovery and higher overall plant efficiency, sometimes called specific energy consumption. Seterusnya, saya akan menceritakan tentang working principle of quench tower. Amount of heat that is removed in the external pump around circuit of a heat transfer section in a column is equal to the exchanger duty Q. The exchanger reduces the pump around liquid temperature from the draw of temperature T1 to the return temperature T2 in a typical design. Q and T1 are usually set by the heat and material balance, and the engineer must select appropriate values of T2 and the pump around red arc. So, boleh lihat rajah tersebut. Terusnya, these variables are related by the following equation. Q sama dengan M Cp total T, Q sama dengan MPa CPL kurungan T1 tolak T2, where Q sama dengan exchanger duty MPa, pump around liquid rate CPL, specific heat capacity of liquid T1, pump around liquid draw of temperature T2, pump around liquid return temperature. Seterusnya, quench tower type, construction and component. Quench tower material of construction. The material of construction are especially important as they must be selected to both withstand attack from the various pollution contained within the extreme and resistant to high incoming temperatures. Common material for construction include Hastelloy AL6XN steel, duplex stainless steel 304 dan 316 stainless steel, refractory and ceramic lining, dan sekali other specialty alloys. Sebenarnya saya akan menunjukkan jenis-jenis quench tower. Yang pertama adalah spray tower, kedua ventral scrubber, ketiga pack tower, keempat GA quench tower dan quench tower high temperature. Seterusnya, saya akan menceritakan tentang advantage and disadvantage of quench tower. Saya memilih 3 jenis quench tower, iaitu spray towers, ventral scrubbers and pack towers. Yang pertama adalah advantage terhadap spray tower. Spray tower can be used for a gas absorber which remove impurities. The design is completely open design. It is simple construct. It is feature eliminate many of the skateboard and plug problem associated with the scrub. It is an expensive control device primarily used for conditioning. It requires very little space and only the amount of water is used that is needed to maintain the desired temperature of the glasses at the discharge. Their installation and operation costs are generally considered to be less than for other cooling method. Spray tower are very effective in removing pollution, particularly from reactor if the pollution are highly. Seterusnya, ventral scrubbers. In fact, tower pressure drop is higher. Packing material increases the cost of the tower. Seterusnya, it is less efficient than cooler. Problem like plugging, fouling and channeling are associated with it. Actually may create water or liquid disposal problem. Terusnya reference. So di sini saya sediakan laman web untuk mencari bahan-bahan tersebut. So anda boleh cari bahan-bahan tersebut di laman web tersebut. Dan itu sahaja daripada saya. Sekian. Terima kasih.